Welcome to Mesh Analysis using KVL and KCL, problem 4. This is our circuit. We have 4 DC voltage sources, 5 resistors, and 1 current source. So I'm starting at I1, the current source, which gives us 3 amps, source clockwise, going down through R1. As you enter each resistive element, put a plus symbol. As you exit, put a minus symbol. As you run into the voltage sources, there's really nothing to calculate or figure out here. The polarity in the voltage is given. I'm going clockwise because that seems to be simple, as the current source itself is going clockwise around the circuit. And we'll need to find the voltage across the current source in this circuit as well. It's unknown. Okay, at this point we could calculate the equation for this mesh, but I would like to touch on our current source. Now, we only have one current source in this loop, but suppose we had two in this single loop here, a 2 amp and a 3 amp. Would you think it would be equal to a 5 amp current source? And what we find with PSpice is no, absolutely not. PSpice does not like to deal with 2 current sources in series. There are a few reasons for this, which we will touch upon shortly. So if you were to make a couple problems yourself and simulate them in PSpice, you're just not going to get anything working with 2 current sources in series. So before we touch upon those reasons, we have a solution that we can find for this mesh. So we're going to solve this. We have 45 volts across R1. It's just simply 3 amps going through that resistor. 3 amps through the 25 ohm resistor gives us 75. And 3 amps through the 50 ohm resistor is 150. The polarity, of course, takes on what we've given through our loop current. R2 is 75 volts, and R3 gives us 30 volts. So the voltage across our current source is going to be equal to, starting from the top right-hand corner, above R1 we get plus 45. We run into the 5-volt source, the minus end, minus 5 volts. Continuing down, we run into 75 volts. Then into plus 150, up through our 1 volt source, which we run into a minus sign, so minus 1, plus 75, plus 2, plus 30, and our 3 volt DC source is minus 3. So we can add these together and we get 368 volts. And this is the voltage across our current source. The simulator gives us a similar result, 3 amps through the entire loop here. That's not too surprising. And our voltage drops with respect to ground. These are not across each element, these are with respect to ground. And these match pretty well with what we found for the voltage drops across each element. Okay, what I'm doing now is setting up an example circuit with initially 1 current source and 1 resistor in PSpice. And we're just going to verify that it works. And then we're going to explore what happens with 2 current sources sharing the same loop. And remember, this is a single closed loop, so this would give us 2 current sources in series. Here we have a current source I1 in series with current source I2 directly. I'm going to try to simulate this and see what happens. So the simulator gives us nothing, and in fact it gives us an error. It tells us we have a couple floating pins or connections. The simulator refuses to handle current sources in series in this manner. So we can look at some of the reasons why this might be the case. So we can consider a single node at the top left-hand corner. We have two current sources going into it. Now, using what we know about Kirchoff's current law, the sum of the currents entering and exiting a node must be equal to 0. So we have 1 amp going into a node from the left side and 1 amp coming into the node from the right side. So there must be some current disappearing into a vacuum or something, simply going nowhere. So that's a violation of KCL. Again, if we reverse the current source, suppose we have 2 amps exiting on the right side, 1 amp coming in on the left side. There's a violation of KCL again, as where's the additional amp coming from? Now, you might be wondering, why not just simply add the two currents together? You can certainly possibly do that. The results also tend to cause some confusion here. So suppose we have 1 amp going into the node and 1 amp exiting. I wonder, do we have 2 amps coming out, or do we only have 1 amp coming out? Just to be a little more clear, suppose we have 1,000 amps on I2 and we only have 1 amp coming out of I1. We get back to our KCL violation once again. So there's 999 amps missing in this equation. Or if we were to continue clockwise, we have 1,001 amps flowing into the node below the 1 amp source. So we're missing quite a bit of amperage here. So this doesn't make sense in the grand scheme of things, and it's certainly not handled at all by PSpice. So this is utter nonsense, pretty much. So not something that we do. We simply don't put two current sources in series. It violates KCL, and the simulator will not handle it. Thank you for watching, and we'll see you in the next video if you would like to try problem number 5.